So decorator objects wrap the other objects and add more functionalities at runtime. Decorator objects have the same supertype as the objects they decorate. And given the supertype of the decorator and the original object is same, the behavior of decorator object is similar to the objects they wrap. So I'll try to link this with a scenario, which is this. We have to design a food billing application which calculates the final bill of the ordered food. Now, user can add extra side food or features to the main food item. So now if I link this with the decorators, then my main food item is a object or is a object of the main food class. Okay, and now this add-on side features or food, they are my decorator objects. And um, the superclass of my main food item and the decorator object should be same, because I mean the superclass of my main food item and the side or extra food items should be same because they are essentially the food items only. Relating it with the real world scenario, let's see if I let's say if I order a pizza, then that pizza is my main food item, and the other extra side food items can be some soft drinks or any other things such as an add-on food item like an ice cream or something. So those are my side food side food items. My main food item is a pizza, and their superclass or their type is same. They both are the food items. Okay, and using the decorators, I'm going to wrap this main food item. So let's move further. Extra side features of food and their combination with the main food items are large in number, and their price also keeps on changing. So what is this saying is that these extra food items which I talked about, some beverage like soft drinks and all, and others sweet dishes or ice creams and all, so they are very large in numbers. So essentially I can't I mean maintain a class for each side food item, right? So that's what it is trying to say, and its price also keeps on changing with time. So I can't attach the price also with these food items. Application should be able to add the side on or add-on features to the main food item at the runtime, which means my main food item I should be able to decorate with the help of my decorator objects. So let's go to the principles once again. Decorator objects wrap the other objects and add more functionalities at runtime. So my here my if I link it with the scenario, then my decorator objects are those side food items which I talked about, like any beverage or any sweet dish or something, and they are going to wrap the main food item, the other objects which is mentioned in the point number 1, and they are going to add more functionalities to it. Decorator objects have the same supertype as the objects to decorate, which I just mentioned. They both are the food items, so their supertype is same. Given the supertype of decorator and original object is same, the behavior of decorator object is similar to the objects they wrap. So if I talk about the behavior of the main food item, then what it can be. It can have description to show like what kind of food item it is. It should be having a price associated with it. Similarly, my decorator food items, my sweet dish or my soft drinks, they also have the same behavior. They have a description attached to it, they have a price attached to it. Okay, so that's why it's saying the behavior of the decorator objects is similar to the objects they wrap. Perfect. So now let's try to design this problem statement with some code. So I talked about main food item, or my main type of object. So this is a interface for those main food items like meal, and I told that they'll have some behavior attached to it. So there is a method called get description, which is going to list or print the description of the food or the meal, and there is a method calculate cost. It's going to print the cost of that meal. There is a main meal class, concrete class, which implements this meal interface, and it is having two data members, description and cost, which I will be passing to the constructor of main meal, and it is overriding these two methods of its interface. Get description, where it is going to return the description, and calculate cost, it's just going to return the cost of this particular main meal object. Okay, my main food type. And then comes the decorators. So if you see this, this is my decorator abstract class add-on meal. I told about that the decorators and the main objects super type is same. So if you see, my decorator class also implements meal, as it is done by my main meal object or class. It also implements meal. My decorator also implements meal. So the behavior is same because it is implementing the same interface. But it also has a meal object or a meal class reference to as a data member, because this decorator object, the objects of add-on meal, which will be my decorator objects, have to wrap the original object. So there is a data member of which is of type of meal, my original object. So I'm going to show how it's going to wrap it. So let's see a concrete implementation of the decorator, which is if I go to add-ons, this is a concrete class which extends add-on meal, which is my decorator abstract class, which in turns implements meal, which is the interface for the all the food items, which is same for the original food item or my decorator food item. So since it extends add-on meal and my add-on meal implements meal, so it also has to override two methods, get description and calculate cost. And similarly, it is going to have two data members, my decorator class, the concrete decorator class, description and cost. And when I'm going to create its object along with description and cost, I'm going to pass this main meal, and it's going to map it here. So what is this main meal? This main meal is coming from this add-on meal, which it extends right here. So now while I'm going to give the description and calculate the cost, as I said, it adds the enhances the feature of the original object. So here also, um, my decorator objects of add-ons, they are going to enhance the description. How? So they are going to add the description of the main meal also, and plus their own description. Similarly, while calculating the cost, they are going to add the cost of the main meal and plus their own cost. So they are enhancing the features or the behavior of my main food object, my main original object, right? So let's see how it's going to work. So there is my bill calculator test class. So herein I'm just creating the object of the main meal, my main food item, and then I'm creating the objects of my add-ons, which are my decorator objects, and I'm passing this main meal here. So just for now, forget about these two lines. Just look at this. I'm creating an object of the main food item, main meal, and then I am creating an object of decorator, and I'm passing the original meal object to it, right? I am decorating the original object in a way, and to the original object also I am passing a description and the food cost, and to this decorator also I'm passing its own description and associated cost. So plus I'm passing the main food item to the decorator. So even if I just comment out this for a second, if I try to run this, so this display bill method will be called and it's going to show the meal description and its cost. So let's see. So it says food is veg pizza and the cost is 350. Simple. Now I add a decorator. To this decorator, as I said, I'll pass this main meal object plus its own description and cost. So let's see how it goes now. So now it's going to say food is veg pizza and extra cheese. Cost is also enhanced, and the description also gets changed. Why? Because if you see this add-ons class, as I said, this add-ons, it's adding the main meal description also and its own description. So it's enhancing the features of the original object. That is what is displayed here. Because now this meal reference is pointing to my decorator object. Okay, so this add-ons also super type is meal, and this main meal also super type is meal. So I can easily ask this reference of meal to point to the decorator object. So now it is printing this. Decorators can also decorate other decorator objects, right? Yes. So let's see here. If I comment out uncomment this, so here when I'm creating the second decorator, I'm passing meal. So now this meal is essentially this object, right, which is a decorator. So to a decorator I'm passing another decorator object, and I'm adding the only the description of this second decorator and its cost. And now when I'm going to run this, so veg pizza, the main meal, extra cheese, the first decorator, and the extra sauce, which is the second decorator, and the cost is a sum of these three costs, right? 450. So a decorator can wrap the main object or the main food item. Decorator can also decorate other decorator also. If I do the same for the third one, so its features will enhance again. So see, veg pizza, extra cheese, extra sauce, chocolate cake, and the cost is a cumulative of all this, right? So go through this interface, abstract class, concrete implementation once again. You will be able to link it with the principles of decorator design pattern, and there is also a scenario which I mentioned, which will help you to identify all those use cases where you should go for decorator design pattern, right? Okay, so thanks a lot friends for watching this, and have a great day. Thank you.